Hello, welcome to Z Talk. In this session, I'd like to talk about running the Elastic Stack on Kubernetes with ECK, which is Elastic Cloud on Kubernetes. This is the new POC I've been playing with recently. All right. So as the starter, I want to talk about some background about this effort first, so that it will be helpful for you to understand my thinking process and the scenarios I've been through before I'm going to this route. All right. So at the very beginning, I have been using a full self-managed ELK stack on my infrastructure as the logging solution, and I got a problem when I was trying to integrate a tracing solution to my infrastructure because it requires the latest version of Elasticsearch as the backend. And unfortunately, at that time, I was not able to upgrade my ELK stack real quick to support that effort due to some historical challenges in my environment. So I had to choose and have been using or testing Elasticsearch service on AWS, as the alternative or trying out solutions for that effort in a kind of small scale of my infrastructure. And recently, as you may also aware, the Elasticsearch service was rebranded by AWS as AWS OpenSearch because Elastic changed their licensing strategy. All new features added after Elasticsearch and Kibana version 7.10.2, if I remember correctly, will not be available. AWS came up with their own solution called OpenSearch, which was built on an older version of Elasticsearch and Kibana. I know it's a little bit confusing here, but basically all we need to know here is that there are going to be two different products or services from now on. One is called OpenSearch, which is specific for AWS, and the other, of course, is the SaaS service provided by Elastic, which is, basically compatible across all the major public cloud vendors like AWS, Azure, or Google. But the problem is that no matter which service I choose here, the challenge is same, which is the cost. So the challenge I had when I was designing on a enterprise logging solution was the cost. Apparently, I guess that's always the headache we have to deal with when we're designing an enterprise solutions, right? So I saw a dramatic cost increase since the migration from the full self-managed ELK solution previously in my infrastructure to OpenSearch. And considering the situation I had was even gonna get worse, because I started integrating Jaeger, the tracing solutions, to my infrastructure to complete my observability platform at a larger scale. And Elasticsearch was designed to be the backend of Jaeger, which apparently is going to further increase the volume of loggings. So I have to consider or reconsider to own and operate Elasticsearch myself to reduce the cost. Because ELK is still open source, free of charge. And if we manage and operate the cluster on my own, I just need to pay for the infrastructure, like computing resources, storage, and cloud, not the service, right? Another thing is that looks like Elasticsearch provided by Elastic has more features than AWS OpenSearch, especially on machine learning capabilities. Again, because OpenSearch was built on an older version of Elasticsearch and Kibana. That's basically why I wanted to reconsider my solution overall. So I'm going to build and run a full self-managed ELK service like before. but I want to have a new design because maintaining a huge L cluster is quite time consuming and challenging. Plus, the trend of applications are moving to the microservices architecture and expansion of the footprint of Kubernetes in my infrastructure. I like to explore if I can also get some benefits of running Elk Stack on Kubernetes. That's basically ECK came into the picture. ECK automates the deployment and orchestration of the Elastic Stack. The operator makes my life easier by taking care of the ECK stack deployment, configuration, and operation. All right. And this diagram here in my slide shows the relationship between ECK and Elasticsearch on Kubernetes. So ECK, again, it's a Kubernetes operator. I think if you watch my previous video about Prometheus operator, you should be familiar with the concept of operator. Basically, operators help extend the types of applications that can run on Kubernetes by allowing developers to provide extra information to applications that need to maintain their states. As we know, that is not something Kubernetes is good at. So ECK installs into your clusters, streamlines many of the operations associated managing, Elasticsearch and Kibana on Kubernetes. I think it's quite relief for us from operating Elk cluster. All right, demo time, my favorite part. So in this demo, I'm gonna walk you through how do I deploy Elastic Stack on Kubernetes via ECK. By the way, please thumb up my video if you think it's kind of useful, and subscribe my channel if you haven't done so. And of course, most importantly, please do feel free to leave comments if you have any questions. I'm really looking forward to hearing your feedback. All right. Next slide here, I'd like to give you a little bit more detail about my demo infrastructure. Here I attached an architectural diagram. This is pretty much the infrastructure I'm gonna build shortly. So the first step of the demo, I'm gonna provision the Kubernetes cluster via a tool called Vagrant. If you're not familiar with Vagrant, Vagrant is a CLI tool that helps you manage your VM software like VirtualBox. Vagrant basically will interact with the VirtualBox API to create and set up the required virtual machines for our cluster. And also, Vagrant orchestrates the provisioning of those VMs. So going forward, I will try to explain my Vagrant configuration along demo as much as I can, but I know Vagrant itself is a big topic. It's totally okay if you're still not that familiar or comfortable with Vagrant after this demo, because honestly, it's not the point of this demo at all. The point, like I mentioned earlier, is to walk you through how do I deploy an Elasticsearch cluster on Kubernetes real quick via ECK. The Vagrant part basically is really just help me to spin up the infrastructure or Kubernetes cluster real quick, is because it really makes your life easier via Vagrant. It's a really popular and powerful DevOps tools that quickly set up your development environments. All right, and oh, by the way, if you are interested in Vagrant and want me talk more about it, I'd love to. Please feel free to leave comments. I will try to make another session specific for Vagrant based on your feedback. Sounds good? All right. Back to the topic. So, as the diagram shows, so once Vagrant finishes the job, we will end up with 3 virtual machines. One VM will be the master node, and the other 2 will be the worker node right here. This is gonna be our 3 nodes Kubernetes cluster. All right, cool. That's pretty much the PPT part. So now let's quickly jump to the demo. All right. One more thing. So I just want to give credit for this repo of Vagrant configuration that I found online. My configuration was built on top of this repo. All right. And I'd like to share this repo with you guys in the description of this video. So feel free to go there, download, and play with it. So, but however, to make it work, we have to make some updates in the configuration because, as you may already aware, you see the timestamp of each file. Looks like this repository has been kind of outdated for a while. So you will run into issues if you just use the existing configuration. You will see. I'll explain in detail. So to start off, the like I mentioned, Vagrant is kind of like quite similar with Docker. So the most important configuration file is this guy called Vagrant file, like Docker file. So the Vagrant file is a Ruby file used to configure Vagrant on a per project basis, and is the entry point of the configuration. And the main function of this Vagrant file is to describe the VMs required for the project, as well as how to configure and provision these machines. All right, so that's pretty much it. So let's jump to the demo. So I will download these repository to my local and open it up in the Visual Studio Code, and I will walk you through firstly with the existing configuration without any change, and let's see what issues we got, what failures we got. Then I will like walk you through how to figure out those issues one by one. All right, sounds good. Quickly jump into my terminal. As you can see, I've cloned the repo to my local. And to start with, I'm just gonna quickly kick off Vagrant with the existing configuration without touching anything. And let's see what error we're gonna get and start from there. Sounds good? All right, so to kick it off, it's pretty easy. Just issue Vagrant up. By the way, sorry. So in order to run these commands, you have to make sure you install Vagrant CLI on your laptop. So I'm on Mac, so I install Vagrant CLI via Homebrew. So just Google instructions for installing Vagrant CLI. If you're in another operating system, it should be pretty straightforward. All right, so once Vagrant CLI is installed, you can verify by issuing something like Vagrant version. Here we go. And if you get something like this, you're good to go. I'm at the latest version. That should be good. So now I'm good to issue Vagrant up. So basically, once you hit this Vagrant up command, Vagrant is going to look for the Vagrant file, these configuration files in the current location. Remember, this is the most important configuration file for Vagrant. It's just like the Docker file for Docker. This is the entry point where we define or describe the virtual machines that we need for our infrastructure. Um, that's basically what happened when you issue the Vagrant app. And back to here, looks like quickly once I hit Vagrant app, it's thrown out an error. And let's take a look. It says the IP address configured for the host-only network is not within the allowed ranges. All right, so this one is an easy fix. So it's kind of common if it was the first time you run Vagrant on your laptop. You probably gonna run into this issue. Basically, the fix is also pretty simple. You just need to define a range of IP that is available to Vagrant for him to, pick up and use it to configure the virtual machines that you request for your infrastructure. All right. So in other words, you just need to the fix is easy. You just need to create a network config file and define a range of IP, which Vagrant is allowed to use for spin up its virtual machines. All right. So let's to fix that. What we need to do, you need to create a folder in the SC directory. So let's see. I'll do make their VBox because this virtual machine software we use is VirtualBox, right? So I create a folder called VBox, and let's log on to that subfolder VBox we just created, and then we just need to create a config file called networks.conf. And inside this file, we just need, like I mentioned, we just need to define like a range of IP that is available for Vagrant, right? So there are two ways. You can define something small like this based on your project. And back to the Visual Studio Code, as you can see here in my Vagrant file, and I create like a private network using IP 172.42.42, and here we go, 172.42.42, right? I was using these IP range. I create these private network to make sure the virtual machines are able to talk with each other, right? So these was the master node, and this is the worker nodes, and they're in the same network. So if for this specific case, I can create like an IP range, like IP setter, something like this. This is a really small IP range for this project, right? Or you can do something like once for all by including these line of code. It basically it's allow every single IP that is available for Vagrant to use. All right. So for this project, I just make it small. I'm gonna use these small range of IPs inside this config, right? And let's save it, and switch back to my previous terminal. Let me clear it out a little bit, and also clean out Vagrant by issue Vagrant destroy to make sure it's gonna be a clear run. So all right, so it's cleared out. Let's do Vagrant one more time. Vagrant up to see what happens this time. All right, it looks promising, and I haven't seen the same issue being reproduced again. Looks like it's fixed. Otherwise, the the error, that connection error should be thrown out like now, right? All right, so looks good. It's moving forward. So I guess it's gonna take a little while to finish up this process. So while we're waiting, so let me switch back to my terminal here. So I will, like I promised, I'll try to explain about these Vagrant file configuration. So again, it's a Ruby file, right? And if you remember the architecture diagram I shared for this demo, I'm gonna create three the Kubernetes cluster. So gonna compose of 3 nodes, 1 master and 2 workers, right? That's exactly what I defined right here in the Vagrant file. So there are gonna be 3 virtual machines being created, and the first section from line 19 to 29, these defines the master nodes, all right? And this section from 31 to 46, and it defines the worker node. And as you can see, we plan to spin up 2 worker nodes, right? That's why the node count equals 2, and I had to use like a for each loop to configure both 2 virtual machines. All right, and going inside of the configuration is pretty human readable and straightforward. So for the VM, I'm gonna use Ubuntu v18 as the operating system, and here I create a private network to make sure, you know, the 3 nodes, the master node and 2 worker nodes, are able to talk with each other. As you can see, the IP range right here and right here, and they're in the same private network, right? And going forward here, we can configure or allocate system resources per virtual machines, right? So as you can see here, the memory allocation, CPU allocation, and remember, so for Kubernetes clusters or Elasticsearch clusters, there are different kinds of nodes, like master nodes and worker nodes. So master node is normally is kind of lightweight, because all it does is acting like a manager to manage the operation of your cluster, right? It does not really take care of the real work, right? So that's why it does not require the same level of system resources allocation as worker nodes do, because worker nodes are the place where real work happens, where heavy lifting happens. That's why, as you can see, the memory allocation is kind of doubled for worker nodes compared with master nodes, right? That's pretty much what you need to do, what you need to know for Vagrant file configuration. Let's switch back to the terminal and let's see how's everything going. And looks is still running, and so far so good. Nothing bad. Oh, oops! Something bad happened just now. See here, looks like there was the connection error. It says it's happened on the master node. It says the connection to the server 172, the 44, the 100 was refused. This doesn't look good. Let's give it another a minute or 2 to let it finish. Then we can try to SSH to these VM or these master nodes to do further investigation. All right. So while we're waiting, let's back to the Visual Studio Code. What else I can explain? Maybe this guy. So as you can see here, above these two sections, there are another configuration called at line 7, and similar things is like at line 28. So in Vagrant, there are different types of provisioners, like shell provisioner, like file provisioner. Basically, so, as you can, I guess easily you can guess. So what this for? So basically, is for it helps Vagrant to provision the virtual machines. So here, for example, this guy, it's gonna use this shell script, bootstrap.sh, this guy, to provision these the virtual machines, because is on the top of the configuration, and it's outside of these section, the master config section and worker section. So it means for both master node and two other worker nodes, it has to run these bootstrap the shell scripts, right? Because it's on top of it, is outside of the scope of this configuration. So this is the generic configuration for every single one in your infrastructure for this case. All right, that's shell provisioners. And we can take a look at the bootstrap shell script here. So basically, what it does, it just install Docker and start Docker. It's pretty straightforward, right? And then it install Kubernetes and enable Kubernetes, something like that. So let's switch back to the terminal and see. All right, so looks like it's done, and we got this error. So it doesn't look good. It says at master node, it timeout waiting for the conditions. So next step, let's SSH or log on to these virtual machine and take a look what's going on. Okay, so before I log into the KMaster VM, so I'd like to do one more check by issuing Vagrant status. Basically, this command returns the status of each VM Vagrant build, right? So here we go, it confirms it's not healthy, because if everything works as expected, all three VM should be running, right? But it's actually not the case. Only the master one is running. But it actually makes sense, because let me switch back to my Visual Studio Code and Vagrant file, right? As you can see, follow the sequence. We define this section, we define the VM for the master, and this section we define the VMs for the two worker nodes. And follow this sequence, Vagrant will create the VM for the master first. But if you remember, the error message happens somewhere here. That's why, back to the terminal, as you can hear, the two worker nodes were not even being created at all, right? Okay, so now let's get access to these VM by issuing Vagrant SSH followed by the name of the box, which is KMaster. All right. Now I'm inside of that VM. So the first thing first, we have to check the status of our Kubernetes cluster. So we can do kubectl get nodes, and looks familiar. That's exactly the same message we saw just now, right? And but it's a good start, because basically when we see these error message, the connection refused error message after we issue kubelets, it points us to the kubelets. So we better check the status of our kubelet service to make sure it's running. So these message high like high probability something going on with our kubelets. So to verify that, let's issue systems ctl status kubelets. All right, that's exactly what I thought. See, for some reason, kubelet is down. It failed to start due to a failure. So now we just need to dig in further to figure out what blocks kubelet from running, right? For that, we have to get more log for kubelets. So let me clear my screen. So we just need to issue journal ctl xeu kubelet. All right. So here it helps us identify the culprit. Here we go. Let me copy that and take it somewhere else so everybody can see. Let me copy that and exit out and clear my screen. And let me jump to my notes. Here we go. I copy the culprit message right here. So basically, you see here, failed to run kubelets because misconfiguration. Kubelet cgroup driver systemd is different from Docker cgroup driver. So that's the root cause. So to explain, to help you understand what's going on with this error message, let me switch back to my Visual Studio Code. Here we go. So as you noticed, above these two sections for defining the VM for master and workers, and at line 7, there is a shell provisioner. Basically, it refers to this shell script to bootstrap.sh. Because it's above or is outside of the section for either master node and worker node, it makes it generic. Basically, it means for every single VM inside of this script, Vagrant requires this script to run for every single VM it's trying to build. That's basically what it means. What it means. So next step, let's take a look at the bootstrap, the shell script. This shell script, and we can see it's pretty straightforward. Basically, it just install the Kubernetes cluster. But before that, we have to install at test 2. We have to install Docker Container Engine to support Kubernetes, right? That's caused a problem because based on the error message, apparently, right now, Kubernetes and Docker, they use different cgroup drivers. But requirement is to make it work, to make kubelet working. Both Kubernetes cluster and Docker, they have to use the same cgroup driver. That's the root cause. So the fix is pretty easy. So we just need to define the native cgroup driver by issuing this JSON file. So here we go. Let me switch back to my notes. We just need to create a file and include this one-liner. So basically, it defines the native cgroup driver as systemd. Right? So we just need to create this file and put it in the Docker folder and recycle. So it should fix the problem. So let's verify this solution first manually by implementing this file to the VM for the master node and to see if it works. If it works, next we can figure out how do we integrate that to the existing Vagrant configuration files, right? So let me jump to my terminal and here we go. So let me get the root permission and I'm gonna create this file under etc docker, and I'm gonna give a name like daemon the YAML file, and then I just copy that one liner here and save. Oh, sorry, it should be JSON. I'll make typo. I'll make it daemon.json. All right, look good. So the next step, we just need to recycle Docker service by systemctl restart Docker and check the status. All right, look, the restart worked, and you see here, these Docker service was just restarted like 5 seconds ago. Look good. And now let's check the stat of the kubelet one more time by issue kubectl. I'm sorry, systemctl status kubelet. All right, it's working. See here? Now it's running. So the solution worked. Now we just need to figure out how do we apply or integrate these fixes to our Vagrant configuration. Cool. All right, quickly jump back to the Vagrant file, and to integrate whatever solution we just tested out manually to the existing repository of Vagrant configuration. So I highlight these section of code that I just added. So you will have to do the similar things on your end if you're playing with that repository that I shared. If you want the whatever we did, that quick fix, be part of the provisioning, right? So basically, I won't talk much detail about Vagrant, but basically I just added another 3 provisioners, like file provisioners and shell provisioners, to perform the fix we did manually, right? That's one thing I updated. Another thing, oh, by the way, don't worry if you need the repository. I will create a new one and share with you the latest one. I'll share both the old one, like I get inspiration from, and the new one on myself, my own repository with my update right here. All right. One more thing. So let's go back to the browser and let's take a look at the documentation of Elastic ECK, right? So for this demo, we're gonna install the latest version of ECK, which is 1.9, right? So let's do a quick start to see the supported version, and you noticed the supported Kubernetes version is from 1.18 to version 1.22. That's going to be another problem in our existing repository. So let's switch back to the repository and go to these go to this bootstrap.sh configuration file. So I explained this already a little bit. So basically, it just follow the procedure to install whatever utilities it needed, like Docker container, and install Kubernetes and from line 54, right? So the problem is here. So I commented these command right here. Basically, just install kubelet, kubeadmin, and kubectl CLI, right? But because the latest version of Kubernetes is 1.23, so apparently based on the documentation back here, so the latest version has not been added to support for Elastic ECK just yet. So we have to make sure we install like a version between 18 and 22, not the latest version, which is 1.23, right? That's why we have to make a little change right here to specify what specific version we want to install for each of the components like kubelet, kubeadmin, and kubectl. That's why I comment this line and give a little bit updates of this command by including the version I want right here. All right, that's pretty much all the changes you have to make if you're also playing the repository on your end. So here I highlight line 57, and plus the other changes I made back to the Vagrant file, and this section from line 11 to line 17. All right, so let's test it out. So let me switch back to my terminal. I already did a Vagrant destroy to wipe out the previous infrastructure, and let's make sure it's going to be another clean run, right? So let's do Vagrant up one more time to see how to go this time. So all those issues we ran into should be all fixed. So we should be able to get a 3 nodes Kubernetes cluster up and running after this provision. All right, looks like the provisionings was done, and let's perform some verification. Firstly, let me clear my screen, and let's issue a Vagrant status. Yeah, this time it looks promising. As you can see, all 3 VMs are up and running. All right, and then let's log on to the master node and take a look the status of the Kubernetes cluster. All right, so let's do a Vagrant SSH kmaster. I'm on the kmaster node, so let's do a kubectl get nodes. All right, as you can see, all 3 nodes are ready, and one more thing to pay attention is the version. So it's v1.22, which is supported by Elastic, right? So all right, all good. So we can move forward to deploy ECK to our Kubernetes cluster, right? Cool. Okay, now we got our Kubernetes cluster up and running. We pretty much finished up the environmental parts, right? So now the next step, we are good to back to the documentation and deploy ECK, the Elastic operator, to our Kubernetes cluster. Just follow the documentation right here. We just need to install the CRD and the operator with its RBAC rules. So what we need to do, just copy and apply these CRD and operator files to our Kubernetes cluster. All right, so here, copy that and switch back to my terminal, and here we go. So one second before I'm doing that, let's do a kubectl get namespace. And once we issue that to apply that to YAML file to our cluster, we should be expecting a new namespace called Elasticsearch being created. Let's see. All right, so CRD has been created, and next one will be the operator. Okay, so let's do a kubectl get namespace one more time, and here we go. As you can see, a new namespace called Elastic System. Let me clear my screen and do a kubectl get namespace one more time. As you can see here, there was a new namespace called Elastic Systems up and running, and let's do a kubectl get pods inside of these namespace. And here we go. The Elastic operator, that ECK, is up and running in our cluster. All right, now we got our operator. We're good to deploy our Elk stack via the Elastic operator, right? Cool. The last piece is quite simple. We just need to follow the instruction on the Elastic documentation to spin up Elasticsearch and Kibana, by creating a YAML config file and applying to our Kubernetes cluster via ECK. All right. So let me quickly jump to my browser, and as you can see here, Elastic gives as example of quick starts, which is a really simple use case. If everything works just fine, we copy this whole section here to our cluster. There should be a single node Elasticsearch cluster being deployed to our Kubernetes cluster, right? But a little note here. In this demo, as we know, we built a development Kubernetes cluster on our local via Vagrant, right? So actually, we needed to do a little bit extra configuration comparing with this one to make it work. So you will see in detail what I'm talking about. So to begin with, how about let's just copy and paste this whole thing without touching anything to our cluster and see what error we're gonna get. All right, let me copy this to my cluster and hit enter. So by the way, I'm just gonna deploy the Elasticsearch and Kibana to my default namespace. All right, and as you can see here, the instance quick start of Elasticsearch was created. So let's check the status of these instance by kubectl get Elasticsearch. All right, the problem is here. As you can see, the health check shows unknown, right? Apparently it doesn't look good, and looks like this instance quick start stuck at this phase calling applying changes. So let's dig in a little bit by checking the status of the pod. Kubectl get PO, and same thing. You can see the quick start pod is stuck in as well. It's showing pending, right? So let's get more information by kubectl describe PO, and here we go. Look at this message. It says 3 pod has unbound immediate persistent volumes. So now the issue was pointed to the PVC. So let's take a look at the PVC by kubectl get PVC, and here we go. Again, it doesn't look good. It's showing pending. So looks like something going on here, and it blocked the PVC from creating a persistent volume for our Elasticsearch pod. So let's do a kubectl get PV, right? It shows no resources found. It does make sense because it's stuck at PVC stage. It's not able to claim a persistent volume. So let's do a little bit dig in here by kubectl describe PVC and copy the name of the PVC here. And this looks like the root cause. This error message was thrown out from a persistent volume controller. It says no persistent volumes available for this claim and no storage class is set. So basically, this error means that there is no persistent volume that can be bound to the persistent volume claim. Because by default, local storage does not really create a persistent volume dynamically. That's why we're getting this error message, right? To fix this issue, a quick workaround is to create a persistent volume manually and attach that persistent volume to our Elasticsearch pod, right? So to fix that, I'm gonna give you an example right here in my Visual Studio Code. So as you can see, before I configure the Elasticsearch instance right here, I add one more step. I'm gonna create a persistent volume right here. Here I'm still gonna use my local storage as the persistent volume, and I'm gonna give the name of this persistent volume as Elasticsearch data, and the type is local. As I mentioned, I'm gonna use the local storage, right? And I'm gonna claim 10G, and I'm gonna mount these persistent volume to here, this host path, mount/data. All right. And then once we got this persistent volume, we're going to attach this persistent volume, copy the name of the Elasticsearch data, attach this PV to my Elasticsearch instance right here. You see here from line 26, volume claim templates, I'm going to attach this Elasticsearch data PV that I just created above right here to these or Elasticsearch instance right here. That's pretty much the extra we have to add to our configuration. And besides that, the rest looks like similar, right? The only difference because it's a single node Elasticsearch cluster, I just make the node acts like both master and data. That's it, right? Okay, so that's pretty much the change I made, and let's just copy this configuration to the master node. And before that, let's do a cuddle delete Elasticsearch quick start. Let's delete everything and make sure it's going to be a fresh start. So do a kubectl get PO. All right, so everything looks like already being deleted. So kubectl get PV. All right, kubectl get PVC. All right, so now everything was wiped out. Let's do a let's just give it a try for another time by just applying that YAML file that I created in my Visual Studio Code, right? All right, and as you can see, I just applied the YAML config to my cluster and the highlight section right here. So you see there was a persistent volume called Elasticsearch-data was created first, which is exactly what we defined in our YAML file, right? So here, see, the Elasticsearch data was created first, and then the quick start instance of Elasticsearch was created afterwards. Let's do another health check to make sure it's working this time by kubectl get Elasticsearch. All right, you see the health check shows green this time. And let's do a kubectl get PO. Same thing. See, the quick start pod is up and running. All right, now let's quickly jump back to the documentation here. Where's my browser? All right, so moving forward, sorry, this one, let's go back to the Elasticsearch cluster. And moving forward, as you can see here, it gives us instruction about how do we get the credential of the default user Elastic. So we can give it a try. You see here is basically it's assign the value of the credential to a variable called password. Right, let's do an echo password. All right, this is our password. And then it shows you how do we request an Elasticsearch endpoint, right? So because we're currently inside of the Kubernetes cluster, we're gonna use kubectl get svc, and there were a couple of Elasticsearch services were created. So to hit the endpoint, we're gonna need to use this cluster IP. So let me just copy the curl command right here and paste it down here, and that's to test the endpoint, we're going to replace here to the cluster IP. Here we go. As you can see, it's working, right? This is the response of that after we hit the Elasticsearch endpoints. All right, so since Elasticsearch cluster is up and running, let's move to Kibana. So let me switch back to my browser and go to the Kibana section, deploy a Kibana instance. Here we go, same thing. Elastic gives us like a quick start, simple use case to test out. So basically, it just connects these So firstly, you're gonna same thing, deploying Kibana to our cluster via ECK, and then here you're gonna connect Kibana to our Elasticsearch cluster right here. See, Elasticsearch Raft, and it point to that instance quick start. All right, so let's do that let me copy the configuration here to my Visual Studio Code. All right, so here it came to the second update that we had to make for our Kibana configuration right here from line 10 to 18. We just tested out the endpoint of Elasticsearch from the master node, right? Which is inside of our Kubernetes cluster. For Elasticsearch is kind of okay because, you know, Elasticsearch acts as the backend or search engine, right? But for Kibana, it's kind of different because, as we know, Kibana is going to be our user interface or front end. So most of cases, we're going to need to get access to Kibana from outside of our Kubernetes cluster, like directly from my laptop, right? So to make that happen, we needed to create a service to expose the Kibana pod to the outside. That's why I update the configuration a little bit from line 10 to 18, basically to change the default service type from cluster IP to node port right here. And I designate a node port 31,560 to these Kibana service. If you are familiar with Kubernetes, you know, for this demo infrastructure, we had multiple nodes, right? We got one master node and another two worker nodes. So by changing the service type from cluster IP to node port, basically Kubernetes will open up these ports, these node ports, on every single worker nodes in the cluster for our access, you know, to the Kibana service from outside. Here, I'm not gonna talk too much about Kubernetes because, you know, it's a huge topic. But if you're interested in Kubernetes administration, you know, I'm working on a series on it. Actually, I already made a session about it weeks ago, so check it out. And let's learn Kubernetes more together over there. All right, so here, back to this topic, I'm just quickly apply this configuration to my cluster. Here, kubectl get get pod. Actually, I already applied the that YAML file for Kibana to my cluster, and as you can see, the Kibana pod is up and running. Kubectl get Kibana, and the health check shows green, so we're good to go. So let's do a kubectl get svc to see the difference we made right here. As you can see, for the Kibana HTTP service, we changed the type from the default cluster IP to node port. Now, and you can see the node port is open, and this is the node port we defined in our YAML, right? So now we're good to access Kibana from outside. Let's quickly test it out. So firstly, let's grab the public IP of these master nodes by IP address here, and here we go. This is the public IP we're going to use to test from outside. So now let's switch back to my browser, which is running on my laptop, right? So let's do a HTTPS and the node port, which is 31,560. Change it to here and hit enter. All right, you see the Kibana interface is loading, and here we go. Now we get access to our Kibana interface from outside of our Kubernetes cluster. All right, so a quick review. We just walked through how we use Vagrant to quickly set up a local, Kubernetes development environment, and then deploy Elasticsearch on top of it via ECK, right? I guess let's call it a day. That's pretty much what I want to share in this session. I know it's already a lot of stuff. So in the next session, we're gonna continue customizing these Elasticsearch cluster by using persistent volume. We just made a quick workaround by manually creating a persistent volume to fix that PVC issue we had when we were deploying Elasticsearch, right? But it's not actually an optimal solution. I'll explain you why in our next video. And also, we're gonna continue customizing to make us an actual multi-node Elasticsearch cluster, more like a production environment. Because right now we just use the quick start, which is just a simple single node cluster, right? We're gonna make it like a multiple Elastic cluster. So let's stay tuned, and we'll talk about more in the next video. And again, thanks for watching, and happy holidays.
Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.